Hello everybody, in this one we are going to decipher the mysterious relationship between the integral on the left side, which goes from -1 to 0, of the function f. We don't even know what the function is, it's okay, we don't have to know it, but we know the value is 4. On the right side we have a seemingly menacing looking integral from 0 to pi over 2 of the same function f. That's a key thing here. But then it takes a negative cosine in here and it has a sine over here. What we want to know is the value of the integral on the right side beginning with the one on the left side. We just have to decipher the relationship. The key would be to recognize that here we have a function and over here we have something very close to its derivative. Once you see that, then variable substitution is a way forward. So to work this out, I am going to let u equal negative cosine x. When I differentiate this will tell me the following, that du equals sine of x dx. And let's stop for a second and recognize an important piece of information. You see, sine of x dx, that's already present right here. So we'll be able to replace sine of x dx with its equivalent, which is du. Just like over here, because u equals negative cosine x, we'll be able to stick u into that position right there within the square brackets. So let's rewrite our integral as a first step. I will go as follows. I will go from f, and instead of writing negative cosine x, that's equal to u, that just becomes u. And instead of writing sine x dx, as you can see, that's just equal to du, so I'm going to put du over here in that position. But there's one more thing to be done, which is this one. Notice that the lower limit of integration is 0 on the right side, and the upper limit of integration is pi over 2. On the left side, we are told limits that go like -1 to 0. The question is, can the limits on the right side, pi over 2 and 0, be transformed into the limits on the left side, -1 and 0, so they match? And we can do that simply by making use of our u equals negative cosine x. So I've zoomed in here a little bit, and let's work that out. Since u equals negative cosine x, so first when x has the value 0, that's going to give me u equals negative cosine of 0. Perhaps you remember from the unit circle that cosine of 0 is 1, but then you multiply by this -1 on the outside, so it's -1. And take a look, you see how this is -1 right here? How that matches now this limit? We want that. Let's also transform x equals pi over 2. So that's going to give us u equals negative cosine of pi over 2. Pi over 2 is the top of the unit circle. There the x-coordinate, which is the cosine function, is 0. So this becomes -1 times 0, which is 0. So now this value represents this upper limit of integration right here. See how they're matching perfectly? Obviously all of this is prearranged in advance. So now let's make replacements as follows. On the bottom of our rewritten integral, for the lower limit, I'm going to put -1, and for the upper limit, I'm going to put 0. So remember the question. The question is, what is the value of this integral given this one right here? Well, by using variable or u substitution, these steps right here, we're able to transform the right side into pretty much something that looks just like the left side. Since the value on the left side is 4, that means the value of our new one, because it has exactly the same structure, it's just that the u is different, but that's not important. That's just a variable. It could be p, z, d, whatever. It's just a letter. So because this integral has the same structure as this one, in other words, this integral simply has to be equal to 4, just like the integral up there on the left side. And that is it. Thanks so much for watching. Please leave a like, it all makes a difference. I'll see you in another one.